Um, okay, the first thing we're going to study in chapter 10 is permutations and combinations. This is technically a math 2 topic, but it's one of those things that hits at the very end of the year. And so some teachers get to it and some teachers don't. So you might have a lot of knowledge about permutations and combinations. You might have zero knowledge about permutations and combinations. I have no idea. So I'm just going to start from scratch. Okay, the first thing I need you to do is just look up at the screen. Okay, this is going to be very simple at first, but I have 4 pens. I have a lot more than 4 pens, but I have 4 pens. I'm going to talk about how many different ways I can arrange these pens. So that is called a permutation. Okay, now there's 4 pens. So I have 4 different spots to put them in. Just think of it that way. Okay, how many different pens do I have to choose from for the first spot? 4. Okay, so I'm just going to choose a random one. Say I picked green. Okay, now how many pens do I have to choose from for the next spot? 3. Okay, so I pick a random one. Okay, and this spot I have 2, and this spot I have what? That's called a permutation. A permutation is an arrangement of different objects. Okay, now on the calculator, I'm going to do a few things on the calculator today. You guys do not need to get yours out right now. Um, I'm just going to first calculate the number of possibilities that we just did for my pens. That would be 4 times 3 times 2 times what? Because there were 4 options for the first spot, 3 options left. For the second spot, 2 options left, and then 1 option left. So that means there are 24 different ways for me to arrange my pens. We call this a permutation, and you can calculate a permutation with this notation. The little n means the total number of objects, and the little r means the number selected. In the example I just did with the pens, the total number of objects I had was 4, and the number that I selected was 4. So that was 4 permutation 4. Okay, permutations have a formula, and this math right here has a name and a symbol. Does anybody know the name of this, doing this math, or the symbol? Oh, true, but very specifically, multiplying by the next number down, multiplying by the next number down, multiplying by the next number down. So this is called a factorial. And a factorial has a symbol. It's called an exclamation mark. Okay, so 4 times 3 times 2 times 1. Notice in your calculator, there's actually, do you ever wonder what this was? If you ever stumbled across it. I don't want to do 24. I want to do 4. We're not doing this on the calculator right now. Don't worry. Don't dig it out. But 4 factorial, which I like to call 4, because it's like you're screaming it because there's an exclamation mark there. 4 is not just 4. It is 4 times 3 times 2 times 1. Okay, so what you do, there's a formula for a permutation. The numerator is the total number of objects factorial, which is what we just did. And then the denominator is the number of objects minus the amount that you're selecting factorial. Okay, so Let's do some examples to make so it makes more sense. Okay. And this guy here, number one, we're going to do with no calculator because on your quiz, you'll have no calculator. But on number 2 or 3, you'll see sometimes the numbers get too big and we have to get a calculator out. Okay, 6 permutation 3. 6 factorial over 6 minus 3 factorial. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And you're wondering, Mrs. Talbot, how could you be so mean as to make me multiply that? But hold on. Okay, the bottom is 3, correct? But it's not just 3, it's 3. So it's 3 times 2 times 1. And then stuff cancels out. So the 1's cancel, and the 2's cancel, and the 3's cancel. And you have 6 times 5, which is 30, times 4, which is 120. So this is saying if you had 6 different pens, oh goodness, I'm about to be embarrassed. Do I have? Okay. If you had 6 different pens, how many different ways can you arrange 3 of them? So here's one way. Here's another way. Here's another way. There's 120 different ways to arrange 3 pens out of 6. That's the question that it's asking. Okay, now this guy is spicy because the numbers are big. So 12 factorial over 12 minus 9 factorial. Okay, and I'm already getting lazy. Do you guys know that the bottom is going to be 3? But not just 3, it's 3. Okay, which means that I'm going to cross out the 3 and the 2 and the 1 in the 12, but I don't want to write them because I'm just too lazy. So 12 times 11 times 10 times 9, 8, 7, 6 times 5 times 4. What happened to my 3, 2, 1? Yeah, great job. Okay, now you can do this on the calculator with the factorial symbol. It's a lot faster, but I'm trying to make sure that you guys understand what's happening. Especially for those of you that it's your first time seeing this ever. 79,833,600. Okay, so there's 79,833,600 different ways to arrange 9 pens out of a total of 12 pens. Okay, now let's go to combination. Combination, the difference between combination and permutation is that for combination, everything is treated as the same. So groups of the same objects. Okay, so write that down first. And then I'm going to go back to the pens for a minute. No. No time, CPT. Okay, so this is going to be really hard to wrap your brain around for a second, but hopefully it will make sense. In a permutation, those are all considered to be different pens. I have a black pen and a green pen and a purple pen and an orange pen. In a combination, they're all just pens. Okay, let me say that again. In a permutation, those are all different pens. In a combination, those are just pens. Okay, so what I mean by that is this is a group of 4 pens. This is the same group of 4 pens. This is the same group of 4 pens. This is the same group of 4 pens. There are a lot less combinations because the repeats don't count. Okay, so what we do, the top is the same. It's the total number of objects arranged. Then you divide by taking out the ones that you're not going to use. And then you divide again by the repeats. Okay. All right, so this one is going to be very easy. And combination numbers, notice this is saying the same thing, saying how many groups of 6 pens can I make out of a total, of 3 pens can I make out of a total of 6 pens? Just pretend they're all the same. Shh. Okay, so the math goes like this, 6 factorial over 6 minus 3 factorial, 3 factorial. So notice you're dividing out the repeats. So 6 times 5 times 4 times 3 times 2 times 1. Okay, this guy right here is 3 times 2 times 1. I'm going to put him in parentheses just so you can see the difference between this one. Okay, now I'm going to do some clever canceling. Do you guys see the 3s and 2s and 1s cancel? You guys got that? Okay, now you could just go straight to the calculator, but I'm too lazy because I see that 3 times 2 is 6, so that cancels those. And all that's left is 5 times 4, which is 20. Okay, next one, 15 factorial. I think this one's going to need the calculator. That's okay. 15 minus 11 factorial, 11 factorial. Okay, now Mrs. Talbot's laziness is going to show up here. Do you guys all see that everything below 11 and below is going to get canceled out of the 15? Okay, so I'm going to write 15 times 14 times 13 times 12. Do you guys all see that? Okay, now on the bottom, this is 4 times 3 times 2 times 1. If you wanted to get fancy, you could cancel out the 12 with this 4 and 3, but since these numbers are so big, I'm just going to go to the calculator. Okay, now we're going to do 4 word problems, and we're going to first decide if it's a permutation or combination, then do the math. This first one, by the way, is really, really big numbers, so just hold on and I'll operate the calculator. Okay. The student body of 100 students wants to elect a president, vice president, secretary, and treasurer. Okay, the only question you have to ask yourself is, are these 4 things the same or different from each other? Different. These 4 things are different, right? Hello? Different? Okay, different means that it's a permutation. So right here, arrangement of different objects. These 4 things are different. You have 100 students and you're taking out 4. President and vice president and secretary and treasurer are all different things. Okay. 100 factorial over 100 minus 4 factorial. Okay, so I know that the bottom is going to be 96. So that means I only need everything to 96. So 100 times 99 times 98 times 97. A lot of different ways. Okay, a group of 30 people need to take an elevator to the top floor. They will go in groups of 6. They are deciding who will take the elevator in the second trip. This, please just ignore that. It doesn't have anything to do with the math. So a group of 30 people need to take an elevator to the top floor. They will go in groups of 6, combination, because they're all the same. So 30 people, groups of 6. Okay. The bottom's going to be 24, correct? So I need 30 times 29 times 28 times 27 times 26 times 25. And then 6 times 5 times 4, 3 times 2 times 1. Now I'm just lazy. I'm going to cancel out the 6 and 5 with the 30. You don't have to do that. Can. Okay. So the main question you need to ask yourself, same or different? Different, same. Yes. Because this, what's 30 minus 6? So everything 24 and below is going to get canceled out because this is on the bottom. Yeah. This is 94,109,400. This is one big number. By the way, your homework is a Google form, and on that Google form, you need to type the commas in to be able to escape. So make sure to put the commas in. Yeah. Okay. Now, 5 out of 19 students will ride in a car instead of a van. Same or different? Combination, they're the same. Okay, now this is going to be 14, correct? 14? Okay, so I only need to 15. Well, okay, this is just how nerdy I am. I just didn't want to cross them out because it wouldn't be pretty anymore. Because they would go through the middle of the thing. But you totally can. You can cancel out the 5 and the 3 and the 15. Um, there's probably other stuff you could cancel too. I just wanted it to be beautiful. Okay, now this, I didn't know enough about sports, so Miss Rice had to explain to me that a captain and a co-captain are not the same thing. Two co-captains are the same thing, but the captain is higher than the co-captain. So that means this is a permutation because those are different. Okay, now can you flip the page over, please, to the next page in the packet? Okay, and I need to explain the homework. That doesn't mean you need to start talking. You just flip a page over. Okay. So, um, okay, your homework is, please stop whatever that is. Okay, your homework is in Google Classroom and it's this. And, I want to talk to you about how it works. And also just tell you that a couple of them in there are cited. Not all cited. But anyway, okay, we're not gonna read this whole thing, but it says that there's 12 teams in around the room. They're all probability permutation combination type problems. When you solve them, you escape. Okay, let me show you the room. Okay, there are 12 spots in the room where your cursor turns into a little hand. So usually it's an arrow, right? And when you can actually click on something, it turns into a hand. Okay, so you're gonna find the 12 spots where it turns into a hand. I'm just gonna go to the first one, which is the teal lady on the wall there. You can't see my mouse for some reason. There's gotta be some kind of setting I can change. I don't know what it is, but you guys all see the lady in the like teal bubble on the wall? Okay, so if you click her, that's number 10. I'm dumb. We don't want number 10. We want number 1. Number 1 is this red fire alarm up on the yellow wall there in the top left corner. Okay. It says, look, you found a clue. Record the answer to this problem for clue number 1. You guys can see where it says number 1, little teeny tiny number over there. Okay. The company wants to create as many 9-digit customer account numbers as possible without changing the first 4 digits. How many account numbers can they create, assuming repeated digits are allowed? Okay, we're gonna do this one together so you can see how the Google form works and stuff. Okay, so find your sheet, find box number 1. And it says, wants to create as many 9-digit customer account numbers as possible without changing the first 4. In a problem like this, I find it best to make a visual. Okay, make a little picture to show your 9 digits of your account number here. Now it says that they're not going to change the first 4, so I'm just going to cancel those out. Those are just going to go away. Okay. How many options of numbers do I have for the first digit? 10. 0 through 9. The numbers 0 through 9. That's 10 numbers. Yeah. Okay. It says, how many account numbers can they create, assuming repeated digits are allowed? So, how many do I have available for the next one? 10, because it said repeats are allowed. Yep. The rest of them actually have permutations and combinations in them, but this one is kind of different. Okay, so this is important. The answer is 100,000, but you need to put the comma in, otherwise the Google form won't work. Need the comma. That's it for number one. Okay, let's see if we can find number two. Number two? No. Number two? That's number five. Okay, let's do number five. 60 students are competing in a video game challenge. If two students compete against each other in every round, how many different combinations can be made for the first round of the challenge? Okay, this one, you're so lucky. It tells you it's combinations. So this one is a combination one. How many total students are there? 60. And how many are going to be competing against each other in every round? 2. So you go to box number 5, which is down here. And that is 60 combination 2. And then you're going to do the problem. Does that make sense? Okay, now, after that, when you have all of them filled in, or you can check them as you go, like my first period kids were doing the first one, then checking it. The way to escape is to click on, I see this column right here in the middle of the room. At the top, there's a little 10 keypad. That's like your lock to unlock it. Okay, so if you click the 10 keypad, it opens up a Google form. And the first thing you do is put your name in. And then clue number 1 is 100,000. And then there's your first one. Does that make sense? And then you try to go through them all. There are a couple spicy ones. Just gonna let you know. You know, you might need me to go over a couple on Monday. Most of them are pretty easy though. Yes. We're not doing this right now though. Okay. Okay, now if you guys could grab your notebooks, please, and thank you. Yeah. Okay, so guys, we will not finish all of this. So if you notice on the stamp sheet, it says 10-1 to 10-6, notes, permutations, and combinations. We did all of that. And then Monday it says finish 10-1 to 10-6. So I don't have any expectations that we're going to finish this. We're just going to do as much of it as we can, just so you know. Okay. Ten one, counting on college. When Angela turned 18, her uncle Zachary explained to her that he had been saving money for her college education since she was born. Lucky girl. He told her that when she was 1 month old, he had put $50 in a safe deposit box, and the month following, he had added $53. He continued adding money like this each month putting in $3 more than he had the previous month. The money that he had saved would now pay for Angela to attend any college of her choosing. Write out the amounts of the deposits for the first few months as an arithmetic sequence. How much was added to Angela's college fund in the 12th month? Okay. So this is actually math one, but we're going to list out the amounts for the first 12 months. So N is the month. And it said that in the first month, he put in $50. So we're right when she was born, when she was 1 month old. And then when she was 2 months old, he put in $53 and continued the pattern all the way until she was 18 years old. Okay, so in month 3, 56, 59, 62, 65, 68, 61. Okay. Any questions about what I did so far? You good? Okay, now we're going to find the equation. So again, we did this in the warm-ups, but this is math one. So arithmetic sequence. A sequence is a number pattern, and arithmetic means I want to be careful when I use the word adding here. It doesn't mean that they are always increasing. You can add a negative and they can go down. They just need to be the same distance apart from each other. Okay, now in this particular sequence, they're going up 3 each time, and we call that D, which is the growth. The other thing that we find when we do the explicit equation is term 0, which would be the number in front. What would be the number in front of this sequence? 47. Okay, the explicit equation is T of n equals D n plus T0. But I like to think of it as y equals mx plus b, just written in sequence notation. For this one, it's T of n equals 3n plus 47, going up by 3 each time, and term 0 is 47. Okay, the last thing we're going to do for number 1 is we're going to figure out how much he put in that final month of her 18th year. So the biggest number that he ever put in. Okay. How many months are there in 18 years? Mm-hmm. So I'm going to plug in 216. The best thing about an explicit equation is being able to get a number that's really far down the sequence because we're just too lazy to write it all the way out to 216 numbers. So the 216th number is going to be 3 times, that's supposed to be a 2. So term 216 is $695. So on the very last month of her 18th year, her uncle put almost $700 in the savings account for her, which is pretty great. I don't have a rich uncle. Really wish he did. But no, it was the student loan train for me. All right, I'm gonna try to do number 2 and then I'll think I'll probably be done. And then we'll do 3 through 6 on Monday. Okay. Number 2. Angela continued to think about Uncle Zachary's savings. Angela wrote the equation for the sequence as T of n equals 47 plus 3n. Uncle Zachary wrote his equation as T of n equals 3 times n minus 1 plus 50. Verify that this equation is equivalent to the equation your team wrote for 10-1 and represents the same sequence. What is the advantage of writing the equation as Angela did? What's the advantage of writing it as Zachary did? Okay, so we're going to write Zachary's here. T of n equals 3 times n minus 1 plus 50. The question is this the same as the one we wrote? Is this the same? Yeah, because you would distribute the 3, and this would become negative 3 plus 50 is 47. Okay, now this is called writing it using the first term, and this is called writing it using term 0. Writing it using term 0 is better because it's easier to plug into. It's much easier to plug a number into this than it is into this. However, this one is better because we don't have to find term 0. We can just use the numbers that were given to us in the problem. Both of these work, and it just kind of depends on your preference most of the time. Okay, now for B, they want us to find out how much money she earned or she got in the first year. Can you guys all trust me to add up all of these numbers or just use my answer from last year? Okay. No, not sure. So $50, $53. Okay, and then a bunch of stuff. And then 83. So this is pretend there's all 12 numbers there. I'm just too lazy to write them. Okay, and then I want you to write something really strange here. That word is Gauss, and that is the name of a mathematician. I'm going to tell you a super cool story about him on Monday. And he figured out a way to add up numbers like that super fast without having to do each one. So I'm going to tell you that on Monday. Gauss. Yeah, he was he was a child genius who was extremely mischievous. Think of him as a very, very naughty genius.